Ladies and gentlemen, today's webinar is on hygiene control in the food and beverage industry, specifically on analyzing ATP, ATP+AMP or A3 and a new way to set fail-pass limits. First of all, I would like to pay my tribute to Dr. Mikio Backe and his colleagues at Kikkoman. He and his group has developed the assay of ATP+ADP+AMP called A3. They have since then successfully applied the A3 assay as an indicator for bacteria, viruses and allergenic food. My presentation today is almost entirely based on their data. I think their work has resulted in a major step forward in rapid hygiene control. So, what is hygiene? Hygiene comes from an ancient Greek word meaning health. The Greeks even had a goddess called Hygeia to preserve health, cleanliness and sanitation. Today it means that bacteria, viruses, allergens that may damage our health or destroy our food must be controlled. Effective and rapid cleaning and hygiene control methods compatible with HACCP are needed. There are two ways to control cleaning of food contact surfaces. First one is specifically measure what can be dangerous in food residues, for example, a certain microorganism or a certain allergenic protein. Testing for several microorganisms or allergens is often laborious and time-consuming. Alternatively, you can unspecifically measure a substance always present in food residues. This substance is then used as an indicator of poor cleaning. No food residues generally means no microorganisms or allergens. The problem is how to set fail-pass limits for accepted cleaning. There are several tests for measuring hygiene. First is aerobic plate count, that's the conventional one. The disadvantage is that it takes one or several days to obtain the results. We have the protein swab, which has a poor sensitivity. We have PCR, laboratory facilities are required and the method does not differentiate between living and dead organisms. Lateral flow immunoassay, several steps in the procedure, takes about 30 minutes. ELISA, again, laboratory facilities are required and it takes around 3 hours. And then we have ATP, which is a rapid test of biological contamination regardless of type of cells, but ATP is susceptible to degradation. And we have A3, ATP+ADP+AMP, rapid and sensitive test for biological contamination, and it's not susceptible to ATP degradation. So we are essentially left with the last two alternatives. So how bad is it that ATP is susceptible to degradation?
Yes, so do you use ATP-related tests? So please do select one of the options you can see on your screen now. And the results will be coming momentarily to your screens. There we go. So 40% said Kikkoman Lucipac Pen or the Lucipac A3. 26% in second place, no ATP related tests. 16% said Hygiene, 12% said Neogen, and just 7% said 3M.
In the video, we will see how bacteria infect food residues and then goes over to food contact surfaces. A surface can be almost sterile after cleaning. In spite of this, food residues can be heavily infected when the production starts the following day. And food is the most abundant substance in food residues after cleaning. and bacteria may grow in food residues between cleaning and start of production. Consequently, it's essential to remove as much as possible of food residues in the cleaning process. ATP is the energy currency in all living cells. It forms when we degrade our food and used when we form new cell constituents or move our muscles. ATP is stable in living cells, but is rapidly degraded when the cells die, and it's degraded to ADP, and ADP is degraded to AMP. The normal ATP test used by all competitors to Kikkoman is measuring only ATP, but there is ATP, ADP and AMP in the sample, but only ATP is measured. And the light emitted from the luciferase reaction is proportional to the ATP concentration. Kikkoman has added two more enzymes, pyruvate kinase and pyruvate orthophosphate dekinase, converting the degradation products of ATP, that is ADP and AMP, back to ATP. Thus, the light signal is proportional to ATP plus ADP plus AMP in the sample, rather than just ATP. This dramatically changes the outcome and the properties of the assay. I don't even like to call A3 an ATP assay, as it's actually measuring ATP plus ADP plus AMP. The upcoming video compares the results obtained with Lumitester A3 with 3 commercially available ATP tests after heavy contamination of a cleaned high-touch surface with a sausage. Only Lumitester A3 detects the contamination, while the ATP tests do not, as ATP in sausage is degraded. The instrument you saw used for the Kikkoman A3 test is called Lumitester Smart. And as you saw, the procedure when using it is exactly the same. And it communicates via Bluetooth to your cell phone or tablet. From these devices, the data can be accessed anywhere in the world. Lumitester Smart has the size and weight of a cell phone. In this slide, the A3 test is compared with 3 commercially available ATP tests. A3 gives similar light readings with ATP, ADP and AMP, surrounded by blue color. The ATP test gives varying signals surrounded by green color, as they contain different luciferase levels. Values surrounded by red color are blanks and should ideally be 0. The A3 assay is linear over 5 orders of magnitude for ATP, ADP and AMP. The regression analysis in this slide was performed after subtracting the blank and calculated on the averages of ATP, ADP and AMP for each concentration. The correlation and linearity is excellent. This slide shows a comparison of the reproducibility of the Lumitester A3 test compared to 3 ATP tests. It involved the application of 10 to the minus 13 mole ATP on 10 swabs of each type, and values are expressed as percentage of the average for each test. Lumitester A3 is obviously the most reproducible test, with a very low spreading. And this is a storage stability test of the reagents performed at 40 degrees. The ATP test lost their activity to 50% in 2 weeks, while the A3 test is more stable.
Okay, so the question is, how did you set your benchmarks? So please select from one of the following options based on the manufacturer's catalogue: validation based on on-site cleaning, comparison with other tests, microorganism test or allergen, determination based on data from serial dilutions of product, or other. And those results will be coming onto your screens in just a moment. There we go. So 39% said validation based on on-site cleaning, and it's a tie for second place in other and also based on manufacturer's catalogue. 25% of you said comparison with other tests, and none of you said determination based on data from serial dilutions of product.
ATP is degraded in buffer by heat, in this case 80 degrees. And you can see that ATP is rapidly degraded while forming ADP, which in turn forms AMP. But the sum of all three is essentially constant, and even more so at alkaline pH. Heat is a normal process in food preparation. And here you have what happens with ATP in poultry carcasses. At slaughter, the ATP is the major constituent, while after 6 hours it has decreased, and after 26 hours it's much less. Storing of food is also a normal process in food manufacturing. When diluting blood 10 times in water, the blood cells undergo lysis, that is, cell membranes open and release ATP and ATP degrading enzymes, which results in ATP being converted to ADP and AMP. In 2 hours, ATP is totally depleted, while A3 is hardly affected. In this example, blood cells were lysed, but a similar reaction will be seen with any food containing cells and exposed to harsh conditions during preparations, while A3 is not affected.